So, in this unit, quantum mechanics, free electron theory, and band theory of solids we will be discussing. We have already done with quantum mechanics chapter. Now we are actually dealing now with free electron theory. First of all, what is actually classical free electron theory and merits and demerits, quantum free electron theory, electrical conductivity equation based on quantum free electron theory, origin of resistance, Fermi-Dirac distribution, density of states, Fermi energy, all these things I will be discussing in this chapter. So according to classical free electron theory, it is proposed by Drude in 1900, in the year 1900, and it was extended by H.R. Lorentz in 1909, and hence this theory is also known as Drude-Lorentz theory. This classical free electron theory is also called as Drude-Lorentz theory because they developed this concept. According to this theory, the free electrons are fully responsible for electrical conduction. According to classical free electron theory, in solids, I mean conductors especially, solids in the sense, free electrons, that means valence shell, free electrons will be there, no? Free electrons are fully responsible for electrical conduction. If no electric field is applied, the free electrons move here and there and make collisions with other free electrons or positive ion cores or walls of the container. Okay, if there is no electric field, the free electrons move here and there. They move here and there, and then they make collisions with other free electrons or positive ion cores or walls of the container. The collision is elastic collision. Okay, the free electrons behave like gaseous molecules in a gaseous container. I already told you, free electrons movement will be like a gaseous molecule in gaseous container. You cannot distinguish between the electron that is belong to this particular atom because all are like freely flowing throughout the positive ion core of the material. The gaseous molecules move here and there within the container and make collisions with other gaseous molecules and with the wall of the container. So the free electrons are called, electron gas. The velocity and energy distribution of the free electron are governed by Maxwell-Boltzmann distribution function. Okay, so the velocity and energy distribution of the free electrons are governed by Maxwell-Boltzmann distribution function. So the average velocity of the free electrons is 0 since they are not able to come out of the specimen. Okay, the average velocity of the free electrons is 0 since they are not able to come out of the specimen. Whenever an electric field is applied, the free electrons acquire some energy from the applied field and they are directed to move away from the field. Okay, so the free electrons acquire some constant velocity due to the applied field and velocity is known as drift velocity. Okay, so when there is no electric field applied, electrons will move here and there like this. They'll be colliding with, walls of the container and then, like gaseous molecules, walls of the container or whatever, and then and move here and there, make collisions with other gaseous molecules. Like that they behave, gaseous molecule. So free electrons are also behave like that. That's why they'll move here and there like this. Under the electric field influence, electrons are forced to move in one particular direction. So they acquire velocity that is called drift velocity. The movement of the electrons in the absence of electric field and during the application of the field is shown below. You can see here how actually it is shown. This is actually classical free electron theory. Okay. Now we'll see. Uh, So the classical free electron theory fails to explain black body radiations, photoelectric effect, Compton effect, etc. So in order to explain the black body radiations, Max Planck proposed the quantum theory of radiation in 1900 year. This concept was used by Einstein in 1905 to explain photoelectric effect. Bohr used this concept in 1911 for his atomic model. He partially succeeded in explaining the hydrogen spectral lines. Compton used this concept to explain Compton scattering in X-rays. Therefore, the quantum concepts were accepted by the scientists during the early stage of the 20th century. Okay, E is equal to h nu, that is according to Planck's radiation law. The energy of electromagnetic radiation is not continuous but discrete. So quantum free electron theory, what it says, in order to rectify the drawbacks of classical free electron theory, Sommerfeld proposed the quantum free electron theory in 1928. This theory was proposed by making slight modification in the classical free electron theory and by retaining most of the postulates of the classical free electron theory. The free electrons are fully responsible for electrical conduction. According to quantum free electron theory, okay, what did they make changes? They modified the classical free electron theory, and they retained most of the postulates of the classical free electron theory, and then they proposed few more. The free electrons are fully responsible for the electrical conduction. The free electron is free to move anywhere within the crystal. The loss of energy due to interaction of the free electron with other free electron or positive ion core or wall of the container is negligible. The free electron behaves as a wave. It has to obey quantum concepts. The velocity and the energy distribution of the free electrons are governed by Fermi-Dirac distribution function. These are the postulates of quantum free electron theory. What are the advantages of quantum free electron theory? This theory explains most of the failures of the classical free electron theory. It explains the specific heat capacity of the materials. It explains quantum effect. This explains Compton effect, photoelectric effect, black body radiation, Zeeman effect. All these are in classical free electron theory we won't get. It gives the correct mathematical expression for the thermal conductivity of metals. It explains the superconducting property. All these things it could explain successfully, this quantum free electron theory. There are certain drawbacks, okay, so that we have gone for another theory. What are the few drawbacks of quantum free electron theory? This theory fails to explain the positive value of Hall coefficients, okay, Hall coefficient based on positive and negative values, we'll try to decide whether it is p type or n type. This quantum free electron theory, majority of the things it could explain, but certain things it could not explain. One of the things is it fails to explain the positive value of the Hall coefficients. This theory fails to distinguish between metal, semiconductor, and insulator. Why actually solids are distinguished like this: metal, semiconductor, and insulators. Okay, it could not explain the correct reason for this behavior of solids, metals, semiconductors, and insulators. So, uh, based on quantum free electron theory, before going to band theory of solids, it could successfully explain all these things, why solids got divided into 3 different types and what are the reasons. We'll just come back soon. According to quantum free electron theory, what is the expression for equation for electrical conductivity? We'll see. Okay, electrical conductivity is defined as the flow of charge carriers in a material due to applied electric field intensity. How we define electrical conductivity is defined as the flow of charge carriers in a material due to applied electric field intensity. Because of that, electrons will try to pass through the material, that is called current. In turn, we say that it is conducting, material is conducting. So electrical conductivity, it will be defined as the flow of charge carriers in a material because of the applied field that you have applied. It is also defined as the reciprocal of the electrical resistivity. It is also defined as the reciprocal of resistivity. Conductivity opposite is resistivity. Units are ohm, inverse, meter, inverse. Consider a specimen is subjected to an electric field of intensity E. Let M be the mass of the electrons and E be the charge of the electron. The force acquired by the electron is minus EE. Okay, so the force acquired by the electron is minus EE. The negative sign shows that electron charge is negative. According to Newton's law of motion, the force is given by F is equal to ma. The equation of motion is written as ma is equal to minus EE. Okay. Then substituting A is equal to dV by dt. Mass into acceleration, force is equal to, according to Newton's second law. A acceleration is equal to dV by dt. If you